Okay, so for problem 2, we're finding the volume of the solid generated by revolving the region bounded by the graph of the equation y equals x squared plus 1 and y equals 0, x equals 0, and x equals 1 along the y-axis. So first we're going to draw out our graph. Okay, so first we have to plot our point. So we're just going to take the equation that we have here, y equals x squared plus 1, and we're just going to plug in random numbers. I'm going to put in 0 squared plus 1, and then y equals, I'm just going to put the 1/2 in, and then I'm going to use 1. And when I plug them in, I get 1 for this one, I get 1.25 for this one, and I get 2 for this one. Okay, so now that we have those points, we're going to start plugging those in. Okay, so 0 is 1, half is 1, 5, and 1 is 2. Okay, so we have a line pretty much that looks like this, a curve, and then we have to take the y equals 0, and we have to do the boundaries. So y equals 0, which is the x boundary, so we just make that a boundary across right here, and then we see that x equals 0, so that's the y boundary that's down to here, and then x equals 1, so that's going to be a boundary right here. And there's no more boundaries, and so now we have to go across the y-axis because that's what they tell us to do. So I'm just gonna copy to the other side. Okay, now that we have that, we're gonna just connect the dots together. Sorry, that was a triple curve. And then draw a line down here. So now that we have that graphed out, we're going to figure out what do we think we're going to use for the formula. So I think because it looks like a cylinder, we're going to use the shell method. Is one of the best ways. So I'm going to use this shell method, which is B equals S BA 2 pi R H. Okay, so now we're just going to basically come out with, we're gonna plug in our thing. So what's our radius? Our radius is going to be x in this stance because it's in the middle, it's at the center. And then our height is going to be our main function, which will be x squared plus 1. So we're just going to plug those in, and we're going to take the 2 pi to the front so it's out of the way. Right, now that we have that, we're just going to start solving for the integral. So I just FOIL this out, get x to the third plus x, bring down everything else, separate the dx. And then we are going to find the derivative, which of x to the third is x to the fourth over 4 plus x squared over 2. And bring down the derivative, or bring down the integral. Now we're going to do the integral. So we're going to have 2, 4 over 4 plus 2 to the squared over 2. And then we're subtracting to the other side, 1 to the 4 power over 4 plus 1 squared over 2. And so we're just going to simplify it more. So we're going to get 4 plus 2, subtract the 1/4 plus 1/2. We can simplify this size even more, making the denominator the same, and we'll get 6 minus 3/4, and still have s 2, 1. Oh yes, and we get a to be 1 and b to be 2 for our limits. And we still have our 2 pi on the outside. And so that we'll have 2 pi on the outside times 21 over 4. And we simplify that even more, we'll get 21 pi over 2, which will be our final answer. And the limits again are 2 to 1.